Hello everybody and welcome back to another video. This is my video on acid-base reactions and stoichiometry. So let's go over this. So in this example, this is a typical problem that the teacher will give you regarding acid-base reactions, and this has got, I believe, titration. So you're trying to figure out how many liters or milliliters of something you need to neutralize either an acid or a base. So let's begin. Okay, so Jar Jar Binks has a 435 milliliter container of 0.775 molar malic acid, H3MuO4 solution. What volume, so that's the question, of 1.15 molar gerium 5 hydroxide is needed to neutralize the sample of malic acid? So first thing you're going to do here is have a balanced chemical equation. Let me show you a trick that my teacher showed me for acid-base titrations. So we have H3MuO4 plus JrOH5. So what do we get when we mix an acid and a base? We know that we get a water and a salt, correct? So right off the bat, you can just do H2 here. But what is the salt? Well, in this case, we have hydrogen, we have mu O4 -3. Because if you look here, this 3 goes over here. We have 5. It says right here, gerium 5 plus, and we have an OH. Remember, OH, the hydroxide, which is right here. It's a polyatomic ion. What I like to do here is this. Just crisscross them. This is water, so I put it there. It's the same thing as saying water. This one is JR. We have this 3, so this 3 goes here. And we have the MuO4. And that has a 5. So you do a 5 right here. And that's gonna be your salt. And another thing noting when working on these, here you see how it says malic acid. Remember when it doesn't say hydro, that means there's oxygen. As you can see there, we have an O4. And another thing to know, just so you know this, is when it says ick, I remember this way, ick 8. So this polyatomic ion should end in 8. And that's why we have a 3 here. That's why I moved this 3 over here. Because of the 8. Remember from naming acids? So this should be, well, it's a made up name, but it should be Mau M- Maulate, I believe. Maulate. That should be the polyatomic ion. And how do we know that it is um an acid? Well, it has hydrogen at the beginning. But again, like I said before, it has a hydrogen, but it has oxygen. That's why it's not hydro, it's malic. And this is 8. No, it's ic 8. So it should be malate. You convert it to ic, so it's malic acid. But you should know how to name your acids as well, and how to properly um, write these chemical names. So let's begin. So this is the neat trick that my teacher showed me. This is your acid, this is your base. So what you do, change color, is the subscript of the hydroxide goes to the acid, and the subscript of the acid goes to the hydroxide. And you multiply these two, which is 15, and you put it in front of the water. And that should balance out the chemical equation. It is that easy. So let's continue. In this case, we are given 435 milliliters of a 0.775 molar acid. I just like to write H3, but I'm lazy, but don't do that. Just write the whole equation. And we are given 1.15 molar, and we don't know the volume. So we're trying to find that of the height of the base. I just like to write OH for the base. So now we already know the balanced chemical equation. There's two things that you gotta know for these problems. One is know how to balance the equation, and two, besides what I've already mentioned before about writing out the formula and naming acids and etc., you need to know how to go from milliliters and molar to moles because we got to do a stoichiometry um, problem to convert moles of the acid to moles of the base. So this is where most of the people that I've shown this really have a hard time, but let me show you how easy this is. So you should know this formula. Molar is equal to N over volume. Molarity is equal to moles over volume. And you know that this is given in moles and this is given in liters, correct? So now that we know that, take a look at this. Since M is equal to moles over liters, what do we have here? We have the molarity and we have a volume. But take a look. We have it in milliliters. We want it in liters. Here's the thing that you gotta know as well. You need to know how to go from milliliters to liters and etc. Because you gotta know your conversion factors. In this case, I'll show you a nice little trick only for milliliters. When you have milliliters, all you gotta do is move back 3. So it's 1, 2, 3. So we have 0.435 liters. That's 5. This is the second thing. How can we find moles of something? Well, it's very easy. If you look at this from an algebraic point, you just multiply the liters on this side and then multiply the liters on this side. So that gives you M times volume is equal to moles. So what do you think I'm going to put up here? Correct. I have liters and I have the molarity. This is the molarity. These are the liters. That's going to give me moles. So what I got to do here is put 0.775 M. So now we type that into a calculator. Let me get answer for you. We have 0.435 times 0.2775. I'm going to use 4 sig figs here. So we have, I like to cancel this out. 0.3371 moles of H3, which translates to acid. get rid of this. This over here. So now we have 0.3371 moles of the acid. Now, if you've done this before, we got to use basic stoichiometry. So, using our chemical formula, we know that for every 5 moles of acid, we get 3 moles of hydroxide. Correct? And here's the second part where most of the people that I've shown this kind of don't understand. So right now, I have moles, moles, moles. We're trying to find volume. What do you think I'm gonna put down here to cancel out the moles? Only using this information given. We only have 1.15 m of a hydroxide. Remember, molarity is moles over liters. So think about it this way. This 1.15 m is really 1.15 moles of the base per 1 liter. What does that tell me? I'm going to put 1.15 m down here. Let me just write that. What I usually do here is just put 1.15 m, but here I'm showing you this way. Over XL. Why XL? Well, 1 is going to give you the same thing. I can either put X here or I can either put 1. It doesn't really matter, but let me show you. If I'm going to put 1, it's not going to really change anything. So now take a look at this. Moles of acid cancel. Moles of acid down here cancel. Moles of base cancel. And the moles down here of base cancel. So now we're just left with the molarity. The molarity of what? The molarity of base. That is all you gotta do here. I just put the moles here, but in reality, this is just the molarity of the base using this expression here. So let's type that into the calculator. And what you can do most of the time is just multiply the first one and then multiply the bottom row. Yeah, multiply all of the first row on the top and multiply all of the bottom row on the top. So we're gonna do 3371 times 3. The bottom is 5 times 1.15. I got 1.0113 over 5.75. And I get 0.17587. But, ojo, remember, molarity is given to you in liters. So these are liters. But we got the answer. Let me make some room here. We have an answer. Just this one. So now we convert this to milliliters. There's 2 ways you can do it, but I'll show you the shortcut. Remember how I went from milliliters to liters. I went 1, 2, 3, and I got 0.35. Just the opposite. You can do 1, 2, 3. I got 1, 7, and this is an 8, so this rounds up. 6 milliliters. That is the final answer.